So when a metal ion is heated, it produces a distinctive flame color. The meaning of distinctive flame color means specific color to that metal. Every metal will have its own special color. So why is it that? Or why is it so? Let's understand it. Stage 1. When a metal ion is heated, it absorbs energy. This energy excites its electron, causing them to move to higher energy levels. That means the electrons which were in the lower energy level, after absorbing heat, the electrons will get excited and they go to the higher energy level. That means more far away from the nucleus. That every element does. Stage 2. The excited electrons release their excess energy as visible light before returning to their regular orbits. That means they go away, release energy, and then they come back or fall back into their original orbit or shells or energy level. Next, stage 3. The difference in the electron arrangement between metals leads to the release of different amount of energy and thus different wavelengths of light. So what is being said is that every element has specific electron arrangement, and therefore they will release different amount of energy, and therefore they have different wavelengths of light. That's why a specific element will have a specific flame when they burn. For example, lithium flame is red. Now we have lithium, sodium, potassium. They belong to alkali metals. Then we have barium and calcium. They belong to alkaline earth metal family. And copper, we all know copper belongs to the transition metals. So let us see their specific colors as in the lab if we had seen it. So let's see. Suppose we take lithium and test it. So what color would you observe? So if you observe very well, it will give you a specific color, and we all know why it will give you a specific color. Why will it give you a specific color? Naturally, a specific color is formed because the electrons will move from lower energy level to higher energy level, and when they come back, they give that energy which they had absorbed in specific wavelength, and therefore they will give you color. So you'll see lithium will burn with a crimson color. Crimson means it's like a reddish color. So lithium has a crimson color. So we can write it down. Lithium ions will give you crimson color. So that's lithium. I hope you understood what crimson is. Let's take sodium now. Sodium will give you a yellow or we can say a golden yellow color. So let's see it again. It will give you a golden yellow color. So sodium will give you a yellow color. Let's take potassium. Potassium will give you a lilac color. That is like we can say purplish. So this is a lilac, a little lighter than eggplant fruit that we get. So this is lilac color. So potassium will give you a lilac color. So that will be lilac. Now let's see what barium gives you. Barium will give you a color like apple green. So let's see how it is. So it's an apple green color. So it will give you an apple green color. Now let's see what calcium gives you. Calcium will give you a brick red color. So it's a brick red color. So we can write that down. Brick red or orange red. So brick red or orange red. Now copper. We are familiar with the copper color. It will give you a bluish green color. So you can see that. It gives you a bluish green or blue green color. So Cu will give you a blue green color. So let's check it once more. So lithium will give you a crimson color. Please write that down. So lithium ions will give you a crimson color. So red. Then sodium ions will give you a yellow color. Then we have potassium ions, is give you a lilac color. Please write down the color because maybe the questions coming up will ask you the color. Barium will give you an apple green color. And then we have calcium will give you a brick red or orange color. Spelling of orange is O-R-A-N-G-E. So correct that spelling. Calcium will give you a brick red or orange color. And copper will give you a blue-green color. So please write down the color. Can we change now? I hope you have understood it. So please write it down and then we can change. Many metal ions can be identified by flame test. We saw it just now. However, precipitation reactions can also be used to identify positive ions, as many metals forms hydroxide precipitate with characteristics color. So remember over here, we are using a hydroxide to identify the precipitate. Usually we use sodium hydroxide. We react it with the metals and we get hydroxide precipitate with specific color. So let's go further. For example, when sodium hydroxide solution is added to a solution of iron 3 chloride, the reaction produces a brown precipitate of iron 3 hydroxide. Can you write this? Now look at this. Precipitation of metal ions. Adding sodium hydroxide to an ionic compound causes the metal ions to form a metal hydroxide precipitate. So let's see how the color changes when we add sodium hydroxide to aluminum ions, calcium ions, magnesium ions, copper ions, iron 2 ions, and iron 3 ions. So let's look at the color changes. Stage 1. So what did we do? When NaOH is added to the ionic solutions, a metal hydroxide precipitate is formed. Some ions can be easily identified by the color of this precipitate. So this is stage 1. Let's go to stage 2. Ions, aluminum will give you white precipitate, calcium will give you white precipitate, magnesium will give you white precipitate, copper will give you blue precipitate, iron 2 plus will give you green, and iron 3 plus will give you red brown precipitate. Now stage 3. Adding an excess of NaOH causes the white aluminum hydroxide precipitate to redissolve. The other precipitate remains in the solid state. So that's the difference between aluminum and the other ions, metal ions. So remember this. What's the summary? Aluminum ions white will dissolve. Calcium white color and no effect. Magnesium also white, no effect. Copper ions blue, no effect. Iron ions green, no effect. And iron 3 ions red brown, no effect. So let's move on. Now, identifying positive ions, ammonia. So ammonia is a positive non-metal ion. It is found in substances like ammonium chloride, so NH4Cl. So this is to identify NH4 positive ions. We already talked about the other metals. Now, in this reaction, you can see when ammonium ions can be identified by adding sodium hydroxide solution. So heating the mixture produces ammonia gas, which turns red litmus to blue. So once again, this reaction can also be used as a test for hydroxide ions. Addition of ammonium chloride will produce ammonium gas in the presence of hydroxide ions.